So today we're going to talk about taking derivatives but in their function form. Okay, so we're used to seeing this. This is our product rule. The derivative of u times v is du times v plus u times dv. Okay, so u and v are commonly known to be functions. This is the function u times the function v. Okay, and technically you're supposed to have dx under the du and the dv. But what happens when we deal with something in its function notation? For instance, if we have r of x is equal to f of x g of x, and we want to find r prime of x, we can think of it in the same terms as this. We're basically doing the product rule, but we're doing product rule of them in their function notation. So we're going to find r prime of x by taking the derivative of f of x and g of x. Okay, so think of it just like we've been doing with product rule. This is u times v. Okay, but this time u is f of x and v is g of x. So r prime, the derivative of r, we have to do product rule. So again, following our format, the derivative of f of x is f prime of x. Okay, times v, which is g of x, plus u, which is f of x, times the derivative of g, which is g prime of x. Okay, so sometimes we take derivatives of things like u and v, sometimes we take derivatives of functions, sometimes we take derivatives of actual polynomials. The process doesn't change no matter what they put here as the derivative. Whether it be x squared or sine x, those are functions. This is the name of that function. So we can't get flustered because this is something the AP test does a lot of. Okay? Similar here, I have h of x is equal to 2 f of x minus 3 g of x. Find h prime of x. Okay, so we're taking the derivative. So here we have the derivative of 2 times f of x. Well, the constant multiple rule says this is just going to be 2 times the derivative of this function, and the derivative of f of x is f prime of x. Minus, because we're using the difference rule, saying that we could take the derivative of this one and this one separately. And again, the constant multiple rule says 3 is just a constant, times the derivative of g of x, which is g prime of x. Okay? So often we'll take the derivative of actual functions. Sometimes we just take them as derivatives of f of x and g of x. It wouldn't be any different as if I had said, okay, h of x is 2 times x squared minus 3 times x cubed. Would you have taken the derivative any different? If I said find h prime of x, well, the only difference is I would have had 2 times the derivative of this, f of x, which would have been 2x, minus 3 times the derivative of x cubed, which would have been 3x squared. I'm still taking the derivative of this one and the derivative of this one here and here. It doesn't make a difference if it's in function notation or if it's the actual polynomial itself.